Good morning, student. In the last classes, we are seeing the chapter three-dimensional geometry. Okay, students, under which we are solving board examination questions. Now, students, we today see some other board examination questions. Okay, so let's start. Our first question is: find the equation of plane passing through the point -1, 3, 2 and perpendicular to each of the plane x plus 2y plus 3z is equal to 5 and 3x plus 3y plus z is equal to 0. Okay, students, so we have to find the equation of plane which is passing through the point. Point is given to us, students, -1, 3, 2. So point is -1, 3, 2. Okay, students, so equation of plane passing through -1, 3, 2 is given by a x minus x1, which is 1, plus b y minus y1 and c z minus z1 is equal to 0. Okay, students, so our equation of plane passing through the point -1, 3, 2 is a x plus 1 plus b y minus 3 plus c z minus 2 is equal to 0. Now, students, question says that and this plane is perpendicular to the two equations of plane. This plane 1 is perpendicular to the plane which is given to us x plus 2y plus 3z. This is 3 straight and perpendicular to the plane 3x plus 3y plus z is equal to 0. 3x plus 3y plus 3x plus 3y plus z is equal to 0. Okay, students, so our plane 1 is perpendicular to the plane this and this. Okay, students, so we know if plane 1 is perpendicular to plane 2, so you know that if the two planes are perpendicular, then we know that condition a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So we write, student, a plus 2b plus 3c is equal to 0. Okay, students, and students, when the plane 1 is perpendicular to plane 3rd, then we get 3a plus 3b plus c is equal to 0. Now, students, these are the two equations and we solve these two equations, students, and find the value of ABC, and the value of ABC we will put in the equation first and get the required result. Okay, students, so now we solve these two equations and we write solving this is 4 and 5th equation, 4 and 5th, we write a by, this will be cancelled, 2 minus 3 3s are 9, and b by, this is cancelled, 9 minus 1, and c, this is cancelled, 3 minus 6. Okay, students, so when we solve this, student, we get the value of A, B, C. Okay students, so we write a by minus 7 and b by 8 is equal to c by minus 3. Okay students, so students, the value of a, b and c are this. So we write this is equal to a constant k. So a is minus 7k student and b is 8k and c is minus 3k. Okay students, so a, b, c are this, and students, now we substitute these value of a, b, c in equation first. So we write put values of a, b, c in equation first, we get, so it will be minus 7k x plus 1 plus 8k y minus 3 minus 3k z minus 2 is equal to 0. Okay students, so this will be minus 7x plus 1 plus 8 y minus 3 minus 3 z minus 2 is equal to 0. Okay students, and students, when we further solve it, we get the required equation. So we write minus 7x plus 8y minus 24 minus 3z plus 6 is equal to 0. So we write minus 7x plus 8y minus 3z is minus 7 minus 24 is minus 31 and plus 6, so this is minus 25. So student, this will be our required equation of plane. Okay, so students, let's see once again what we have done in this question overall. Let's see, our question is that we have to find the equation of plane which is passing through the point minus 1, 3, 2, and this plane is perpendicular to the plane this and this. Okay students, so we have to find the equation of plane that is passing through the point minus 1, 3, 2. Okay, so students, our equation first is equation of plane passing through the point minus 1, 3, 2 is given by a x plus 1 plus b y minus 3 c z minus 2 is equal to 0. Question first, and students, equation 1 is perpendicular to the plane, that is x plus 2y plus 3z is equal to 0 and 3x plus 3y plus z is equal to 0. This is equation number 3 students. Now students, our question says that equation passes through that point is perpendicular to this and this. So students, our A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So we write A plus 2B plus 3C is 0. And students, again 3A plus 3B plus C is equal to 0. So this is again students equation number 4. And students, solving this 4 and 5. Now students, solving this 4 and 5 using cross multiplication method, we write a by 2 minus 9, b by 9 minus 1, c by 3 minus 6 and get a by minus 7, b by 8, c by minus 3. And students, we take that this is equal to a constant k. So our a, b, c is like this, and we substitute this value of a, b, c in equation first, and we get, after solving, we get the equation of plane. Okay students, so I hope you understand students. Now we move to next question. So next question is, student, find the image of the point having position vector I plus 3z plus 4k in the plane R 2I minus j plus k minus j plus k 2I minus j plus k plus 3 is equal to 0. Okay, students. So this is our question. So first of all, we are taking the points 1, 3, 4, and this is when we change this in Cartesian form, we write 2x minus y plus z plus 3 is equal to 0. Okay, students. So if this is the plane and there is a point A whose coordinate is 1, 3, 4. Okay, students, whose coordinate is 1, 3, 4, and the plane, the equation of plane is 2x minus y plus z plus 3 is equal to 0, students. So we have to find the coordinate of point B. Okay, students, and let this is the intersection point of A and B. So our coordinate of the coordinate of point B, let the image of point B is alpha, beta and gamma. Okay, students, so alpha, beta and gamma is the image of the point point A, which is alpha, beta, gamma. Okay, students, and students, you know the point, the object which is from the intersection point of the line and plane is at the equal distance from here to here. Okay, so the image, the distance from this point to B and this point to A will be equal. So this will be the midpoint. Okay, students, and it's so this is the midpoint, students. So first of all, students, we find the equation of this line. Okay, so first of all, we find the equation of the line AP. Okay, students. Okay, students. So, students, first of all, we find the equation of this line AP, which is passing to the point 1, 3, 4. Okay, students. So, find the equation of line AP. What we will do, students? We want the point and the direction ratio. Okay. So, point is given to us 1, 3, 4, but direction ratio is what? So, we are seeing that this line is perpendicular to this plane. So, the normal of this plane is parallel to this line. So, its direction will be what? 2 minus 1, 1. So, the equation of line AP is what? X minus x1 by direction is 2, y minus 3 by minus 1, and z minus 4 by 1. Okay, students, so this is the direction ratio of the normal to the plane, which is parallel to the line. Okay, now students, we are saying that if we suppose the coordinate of this point is x1, y1, z1, then what will be it? So, point P satisfy the line and plane, student. This point is the intersection point of line and plane. So it will satisfy the equation of line and plane. So we can write at the place of this x1 minus 1 by 2 and y1 minus 3 by minus 1 and z1 minus 4 by 1. And suppose that this is equal to the coordinate, equal to the constant lambda. So x1 will be 2 lambda plus 1 and y1 will be minus lambda plus 3 and z1 will be lambda plus 4. Okay students, so x1, y1, z1 is this. Okay. Now students, we are seeing that this x1, y1, z1 satisfy the equation of plane. So we write equation of plane satisfy the point, the above point. So students, we write 2 lambda plus 1 minus lambda plus 3 plus z lambda plus 4 plus 3 is equal to 0. 4 lambda plus 2 plus lambda minus 3 plus lambda plus 7 is, so lambda, 4 lambda and 2 lambda, 6 lambda, and students 7 and 2, 9 minus 3, 6. So students, we are getting our lambda is equal to 1. Okay students, so after solving these two, what we are getting, this is plus 6 and this is minus 1. Okay, so 6 and 4 and 2 6 and 6 to 9 minus 3 is 6, and when we send this side, so we get our lambda is minus 1. Okay students, now we find the coordinate of, okay, so x1 is minus 1 and y1 is 4 and z1 is 3. So coordinate of minus 1, 4, 3 is, so student, coordinate of point P is minus 1, 4, 3. Okay students, and now students, we find the image. You know students, the image is the equal distance from the plane equal to the distance of the object. Okay, so we write, so this P is the midpoint, so we write minus 1 is equal to 1 plus alpha by 2. So it will be students minus 2 minus 1 is equal to alpha. So this is alpha is minus 3, and students, our beta, which is 4, that is 3 beta, which is 3 plus 3 and plus beta by 2. Okay students, so we write this is, so all beta is 8 minus 3, that is 5, and gamma is 3, which is equal to 4 plus gamma by 2. So this is 6 minus 4, that is 2. So students, our point is minus 3, 5 and 2. Okay students, so the image of the point is, students, in this way we have find out minus 3, 5, 2. Okay students, so in this way we can find out the image of the point. Okay, let's see once again students. Our question is, we have to given this is the position vector and this is the equation of plane. We have to find the image of this point in this plane. Okay, so first of all, students, we have taken the point 1, 3, 4 from here and convert this vector equation in the Cartesian equation 2x minus y plus z plus 3 is equal to 0, students. So our students, we have taken, this is our point A and this is our plane, and in this plane we have find the image of the point which we have taken alpha, beta, gamma. Okay, so our equation of line AP will be what? X minus 1 by 2, y minus 3 by minus 1, z minus 4 by 1. Students, equation of plane passing through one point is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. And students, where a, b, c is the direction ratio, so we are seeing that this is the point is given to us x1, y1, z1, but the direction ratio is not. But we are seeing that this line is parallel to the direction ratio to the normal, okay, of the plane. So the direction ratio will be same. So we can use 2 minus 1, 1, direction ratio normal to the plane, which is 2 minus 1, 1, okay. So our equation of line will be this. Now point P satisfying the line and plane. Okay, students, so x1 minus 1 by 2 and y1 minus 3 by minus 1, z minus 4 by 1 is equal to lambda. We have taken the x1, y1, z1 is the intersection point of this line and plane. So it will satisfy both line and plane. So it will be x1, y1, z1. We have suppose this is equal to the lambda, students. So our x1 is 2 lambda plus 1 and y1 is minus lambda plus 3 and z1 is lambda plus 4. Okay, so equation of plane that satisfy the above point also. So students, we use the place of 2x is x1, y is y1, z is z1, and you know the x1, z1, y1, the values we can substitute at the place of him. So we write and 2 lambda plus 1 minus lambda plus 3, lambda plus 4 plus 3 is equal to 0. So after solving this, we get the lambda is minus 1, students, and x1. After getting lambda, we substitute value minus 1 here and here. Then we get our coordinate is minus 1, 4, 3. Okay, students. Now, students, we have find out this point. You know, the image is the midpoint of this and this. So because the distance from the mirror to the object and the image are same, so that point will be midpoint. So we use the midpoint formula, that is x1 is x1 plus x2 upon 2, and here we write minus 1 is 1 plus alpha by 2, so alpha is minus 3, and 4 is equal to 3 plus beta by 2, which is beta is 5, and 3 is 4 plus lambda by 2, so our gamma is 2. So in this way, our coordinate of image is minus 3, 5, 2. Okay, students, I hope you understand. Okay, students, now we move to next question. The next question is, students, find the distance between the point and the plane determined by the point A, B and C. Okay, so next question is, we have to find the distance between the point 7 to 4 and the plane determined by the point A, which is 2, 5, minus 3, 2, 5, minus 3, and students, B is minus 2, minus 3, 5, minus 2, minus 3, 5, and C is 5, 3 minus 3. 5, 3 minus 3. So students, first of all, we have to find the equation of the plane, and then from this point to this plane, we find the perpendicular distance. Okay, students. So, equation of plane passing through 3 points is given by x minus x1, y minus y1, z minus z1, x2 minus x1, x3 minus x1, y2 minus y1, y3 minus y1, z2 minus z1, z3 minus z1 is equal to 0. Okay, students. So, students, this is, now we substitute the value. This is x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay, students, now we substitute all the values. X minus x1 is 2, y minus y1 is 5, z minus z1 is 3, and x2 minus x1 is this, y2 minus y1 and z2 minus z1 is 10, and x3 minus x1 5 minus 2 and y3 3 minus 5 and z3 minus 3 minus 1. Okay, students. So we write x minus 2, y minus 5, z plus 3 minus 4 minus 8, and this is 8 and 3 minus 2 and 0. Okay, students. So now, students, when we expand this, we get the equation of plane. So x minus 2, 0 minus plus 60 minus y minus 5, this is cancelled 0, minus 24, z plus 3, again this part is cancelled, 8 minus plus 24 is 0. Okay, students. Now x minus 2 and 16, y minus 5 minus 24 and z plus 3 and 32. Okay, students, now we multiply this, we get 16x minus 32, and this is plus 24y, and this is minus 120 plus 32z plus 6 is equal to 0. Okay, students. Now, students, we further write this 16x, 24y and 32z, and students, this is minus 24 and 32, and this is minus 56. Okay, so students, now students, we take common 8, so we write 2x plus 3y, 4z, 7 is 0. And students, now what we have to do in this question, we have to find the distance, perpendicular distance from this point to this plane is, so we write the distance from 7 to 4 to plane 1 is AX1, so we write 3 into 2 plus 4 into 4 minus 7 by under root 4 plus 9 plus 16. So this will be 14 plus 6 is 16 minus 7 by this is okay students. So 16 and 14 is 30 and minus 1 29 by root 29. Okay students, so this will be our root 29 units, the distance. Okay students, I hope you understand. First of all students, we have find the equation of plane passing through the 3 points. As you know, we are already known about the formula. Passing through 3 points is x minus x1, y minus y1, z minus z1, x minus x1, y minus y1, z minus z1, x minus x1, y3 minus y1, z3 minus z1 is equal to 0 in the determinant. Okay, when we substitute the value students and expand this, we get the equation of plane, which is 2x plus 3y plus 4z minus 7 is 0. Okay students, and the point given point to the perpendicular to the plane, the distance will be this root 29. Okay, I hope you understand students. Okay.